Hello grade 8 children. Today I am here to teach you chapter 10 in your textbook that's called Indices. You started Indices in grade 7, so we'll look at more properties. So what are indices? Powers, or another name for a power we can say exponents. Now we'll take this number 3, 3, 3 several times. So how many 3's are there? 1, 2, 3, 4, 5, 6. So we can write this number as 3 to the power 6. So when you take this number, so here 6 is the superscript. So what is that? That's the index. Index is the singular and indices is the plural form. And what is this number? 3 is the base. So we know the base and the power. And we call this whole thing as the index notation. Write down how you read the following, how you do that. 3 to the power of 6. What is this one? 7 to the power of 7 to the power of 3. 10 to the power of 2. 2, or you can write the number. So here I can write number 2. What's this one? 8 to the power of 4. 8 to the power of 4. This one, 9 to the power of 3. And now a letter. So how can you read this? A to the power of 4. So now you know how to read these index notations. Write the following indicating the index notation. 2 to the power of 3. 2 to the power of 3. 3 to the power of 4. 5 to the power of 8. 8 to the power of 4. X to the power of 3. Y to the power of 9. Now you have given the index notation and you are asked to write down the base and the index. So what's the base? Base is 3 here. What's the index? 4. When you take this one, base is 7, index is 4. Here base is 10, index is 3. Base is 8, index is 5. And here base is 9, index is 3. Here base is A, index is 4. And here, what's the base? Y is the base and the index is 3. Write the following in index notation. So what's the base? 7. How many 7's are there? 1, 2, 3, 4. 7 to the power of 4. 8 is the base. How many 8's are there? 1, 2, 3, 4. 8 to the power of 4. Minus 10 is the base. Now, how many? 1, 2, 3. 11 is the base now. How many 11's? 1, 2, 3, 4. 11 to the power of 4. Here, how many A's are there? 1, 2, 3, 4, 5. A to the power 5. How many Y's are there? 1, 2, 3, 4, 5. Y to the power 5. Write the following expanded as product of numbers. Now 5 to the power of 3. How can you expand that? 5 3 times. 7 to the power of 4. 7 4 times. Minus 3 to the power of 4. Minus 3 4 times. Then 8 to the power 5. 8 you have to write 5 times. X to the power 4 means x 4 times. So don't get confused with this multiplication sign and x. Y to the power 5 means y 5 times. Write the following expanded form. So 2a squared, that means twice, and b. 3x squared, that means 2 x's and y. How you write this one? 5 and 3 a's. This one 7. How many x's are there? 2. And how many y's are there? 2. The other one. 11 is there. 2 p's. P squared means p into p. And then 1 q value. This one you write 2. 3 a's are there. So you write 3 a's and 1 b. Here 3 twice and a thrice and 1b. Here 5 2 times. 1x, 3 y's. This one 2 sevens and 3 a's. Here 2 and 4 x's and 1 y. Write the following index notation. 2 is there. How many x's? 1, 2. So 2 there and 1 y. Here how many 3's? 2 3's. So 3 to the power 2. And how many a's? 2 a's and 1 b. Here you don't need to put 1 there. How many 5's? 3 5's and 2 x's. X squared. 2 7's and 3 p's. P to the power 3. Here 3 11's and 2 m's. M squared. This one 2 9's. So 9 squared. 1 2. 2 x's and 2 y's. Now try to write down this. 2 8's, 2 m's and 1 n. Here 13 is there. 2 p's and 3 q's. Here 4, 2 a's and 3 b's. This one 1 3. Here 2 a's and 1 b and 2 c's. Write the following numbers as a product of prime numbers and write them in index notation. So we need to find out what are the prime factors. Take 8, divide by 2, you get 4. Divide by 2 again, you get 2. Divide by 2 again, you get 1. So 8 you can write 2 times 2 times 2. Now you can write this in index notation. How many 2's are there? 1, 2, 3. So 2 to the power 3. 9, how can you write? Take 9 and you can divide by 3. You get 1. So 3 times 3. 2 3's are there. You can write as 3 squared. 12. Find the factors. Divide by 2, 6. Divide by 2 again, 3. Divide by 3 again, 1. So you can write 2 times 2 times 3. This is same as 2 to the power 2 and 3 to the power 1. This one, 30. Divide by 2, you get 15. Divide by 3, you get 5. Divide by 5, you get 1. So 2 times 3 times 5. So you can't do anything. You can't simplify because all these prime factors only once. 20. Divide by 2, you get 10. Divide by 2, 5. You get 1. So you can write 2 times 2 times 5. Simplify this. You get 2 2's and 1 5. No need to put 1 there. 36. Divide by 2, you get 18. Divide by 2, 9. Divide by 3, you get 3. Divide by 3 again, you get 1. 2 times 2 times 3 times 3. 2 2's and 2 3's. So you can write like that. 100. Divide by 2, get 50. Divide by 2 again, you get 25. Now you can divide by 5. That's 5. Divide by 5 again, you get 1. So I can write 2 times 2 times 5 times 5. Simplify and I can write 2 to the power 2 and 5 to the power 2. 72. Divide and get the prime factors. Divide by 2, you get 36. Divide by 2, 80. Divide by 2, 9. Divide by 3, 3. You get 1. So 2 times 2 times 2 times 3 and another 3. So how can you write? 2 to the power 3 and 3 to the power 2. 162. Divide by 2, you get 81. Divide by 3, you get 27. Divide by 3 again, 9. 3 again, 3. Divide by 3, you get 1. So 2 times 3 3's, not 3 3's, 4 3's. So how can you write? 2 into 3 to the power 4. 225. Divide by 3, you get 7 and 5, 75. Divide by 5, you can divide by 3 again. Divide by 3 again, 2 and 5. Now you can divide by 5, that's 1. 3 into 3 and 5 into 5. I can write 3 squared and 5 squared as index notation. Expand the following and write down the value. 2 squared, that means 2 into 2. 3 squared means 3 into 3. Now what's the value? 2 times 2, 4. 4 times 3, 12. 12 times 3, 36. This one, 3 squared, that means 3 times 3 and then 1, 5. 3 times 3, 9. 9 times 5, 45. Here 7 times 7 times 11. 49 times 11. Multiply this by 11. 10 and 1. You get 9. 3 and 5. 539. So you know how you get this one at once. When you are multiplying by 11, you first write down the last digit and then 9 plus 4, 13, 1 remaining, and you are adding that 1 to that. So 539. So you can use that. 539. This one, 3 to the power 3 is 27. 3 times 3 times 3. 5 squared, 5 and 5. So 3 times 3, 9. 9 times 3, 27. 27 times 25. 20 and 5. You get 675. So check it again. You can multiply by 20 and 5. And when you add, you are getting 675. 3 squared means 3 times 3. 7 squared means 7 times 7. Now multiply. 3 times 3, 9. 9 times 7, 63. 63 times 7. 441. Or you can check with 21 into 21. 21 squared. 2 to the power 4. 2, 4 times. 1, 2, 3, 4. And 1, 3. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3. What's the value? 48. This one. 11 times 11 times 13. 11 times 11, we know that it's 121. 121 times 13. 10 and 3, you get 363. When you add it, 1573. This one. 5 to the power 3. 5 times 5 times 5 into 7. 5 times 5, 25. 25 times 5, 125. 125 multiplied by 7. 35. 14 plus 3, 17. 7 plus 1, 8. So 875. This one, 2 4 times and 5 twice. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 5, 80. And 80 times 5, 400. This one, 3 to the power 4. 3 into 3 into 3 into 3 and 2 5s. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. 81 times 5, 405. Again multiply by 5. You get 2025. Power of a product. As a product of powers 3 into 5 squared, here is the product of 3 and 5 written as a power of 2. So this is power of 2. So that means you can write this one as this multiplied by this, twice of that. Then we can separate it. How many 3's are there? 1, 2. How many 5's are there? 2. Then what's the value? We can write as 3 squared and 5 squared. Now this is power of a product. Power of a product we can write as separate powers. Write down as product of powers. 2 into 5 to the power 3 means 2 into 5, 3 times. Then how many 2's are there? 1, 2, 3. How many 5's? 1, 2, 3. Then you can count separately. 2 to the power 3 and 5 to the power 3. So what's the answer? You can write 2 into 5 power 3 as 2 to the power 3 and 5 to the power 3. Now look at this one, xy to the power 3. So that means xy, 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 3 times. How many x's are there? 1, 2, 3. How many y's? 1, 2, 3. Now you can write separately how many x's? 3. How many y's? That's 3. Here you don't need to write multiplication sign. You can write as x to the power 3, y to the power 3. Now look at carefully. Can you see? We are considering power 3 at once. So we can use that. No need to expand it and get the answer. When you see a power, this power you have to consider for all numbers or letters as this power. So when this is power 3, x to the power 3 and y to the power 3. Write down as product of powers. So we need to look at 8. When you take 8, you can divide by 2 and write 4. Divide by 2 again, that's 2. Divide by 2 again, you get 1. So 8 I can write 2 times 2 times 2 times A3 and B2. Now, how many 2's are there? 2 to the power 3, A to the power 3 and B square. Now we can see all are powers. 2 to the power 3 into A to the power 3 and B to the power 2. Write down as product of powers of PQR. So now you can see this one is PQR, PQR and another PQR. How many P's are there? 3. How many Q's? Another 3. How many R? You get 3. So you can write P to the power 3, Q to the power 3 and R to the power 3. So look at carefully. When there's a power outside, consider the power for all inside numbers or letters. So P to the power 3, Q to the power 3 and R to the power 3. So you can write at once. Write down as product of powers. What's the answer? If you are doing at once, you need to get 3 to the power 3 and x to the power 3. We'll check that. So 3x 3 times. Then how many 3's are there? 3 3's and 3 x's. You can write this one as 1, 2, 3 and x to the power 3. So you get the same answer. Write down as product of powers. Now how you do that? If you are writing at once, we know you are getting 5 to the power 3, x to the power 3 and y to the power 3. So we'll check it. 5xy, 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 3 times. Now, how many 5s are there? 1, 2, 3. How many x's? 1, 2, 3. How many y's are there? 1, 2, 3. Now you can write as powers. 5 to the power 3, x to the power 3 and y to the power 3. Write down as product of powers. So what's the answer? 7 squared, a squared, b squared and c squared. So you have to consider this outside power for all inside letters and numbers. So this should be the answer. We'll check it. 7abc twice. 2 7s, 2 a's, 2 b's and 2 c's. So how can you write as a power? 7 to the power 2, a to the power 2, b to the power 2 and c to the power 2. So without the multiplication sign, you can write like this. Write down as product of powers at once. Now you know the pattern. So what you do? You take the powers for all inside numbers. 2 to the power 2, 7 to the power 2. This one 3 to the power 2 and 5 to the power 2. 7 to the power 3, 11 to the power 3. Here 2 to the power 4 and 3 to the power 4. This one a to the power 3 and b to the power 3. This one you get 3 numbers. So same thing, 2 to the power 2, 3 to the power 2 and 5 to the power 2. This one 3 to the power 3, 5 to the power 3 and 7 to the power 3. Here you don't need to write down multiplication when there's letters. A to the power 5, b to the power 5, c to the power 5. This one x to the power 3, y to the power 3, z to the power 3. This one 5 to the power 3, a to the power 3 and b to the power 3. Write down power of product as product of powers. So this is something power. One expression with a power, you have to write down separate powers. You can write 3 to the power 3 and a to the power 3. Or you can write without multiplication sign, but it says product of powers. So you show like this. 5 to the power 2 and x to the power 2. 6 to the power 3 and m to the power 3 here. 10 to the power 2 with x to the power 2. 3 to the power 4 and y to the power 4. Here 5 to the power 3 and p to the power 3. This one a to the power 4, b to the power 4. M to the power 3 and n to the power 3 here. 2 to the power 3, p to the power 3 and q to the power 3. Here 3 squared, x squared and y squared. 5 to the power 3, p to the power 3 and q to the power 3. What about the last one? 11 to the power 3, x to the power 3 and y to the power 3. Write down product of powers as power of a product. So you have to combine. So look at this one, same power. So I can write power is 3 and 5 and 7 inside. This one, same power, power 2. Instead of this, I can write 4 times 7. Same power you can take like this, not with different powers. 3 times x or 3x to the power 4 also you can write. P and Q with power 2 here. A and B with power 3. This one 3 terms are there. 2, 5 and x with the power 4. This one 3 and P, same power. Same power you can write like this. Power 3, so 7 times y with power 3. Here m and n with power 4. 11 and y with power 4. This one 2 and y with power 7. 5 and p with power 4. Power of a negative integer. So now inside there's a negative number. So negative 2 to the power 1 is negative 2. Negative 2 to the power 2 means you multiply twice. So what's the answer? 2 times 2, 4, and minus into minus becomes plus. Power 3, you have to multiply 3 times. So you get 8, 2 times 2 times 2. Minus into minus plus, plus into minus, you get minus 8. When it comes to 2 to the power 4, minus 2 to the power 4, you are multiplying this answer by another minus 2. You are getting 16 with positive. This one, 16 times another 2, you get 32, but this is minus. So what can you observe? 2 to the power 1. Minus 2 to the power 1, minus 2 to the power 3, minus 2 to the power 5. For odd powers, always get negative values. And odd power of negative integer is always a negative value. So you need to remember, when there's a negative sign, when you take any odd power, the answer is negative. Look at the other one. When it comes to even powers, what's the answer? You get positive values. So even power of negative integer is always positive. Power of a positive integer. Now look at this one. 2 to the power 1 is 2. 2 to the power 2, you get 4. 2 to the power 3, 4 times 2, 8. 2 to the power 4, 8 times 2, 16. Again, you have to multiply by 2, you get 32. So, we can see all these numbers are positive. So, power of a positive integer is always positive. Now, look at this one. 1 is 1. 1 squared, 1 times 1, 1. 1 to the power 3, you get 1 there. 1 to the power 4, also 1. Look at this one, minus 1 to the power 1, minus 1. Minus 1 to the power 2, you get positive 1 because minus minus positive. Here 3 numbers, so you get negative 1. Here negative 1 times negative 1, you get positive 1 as well. Now observe that any power of 1 is always 1. Odd power of negative 1. This one, you are always getting minus 1. Even power of negative 1, you are always getting positive 1. So remember that 1 to the power 101 is 1. Negative 1 to the power 99. What is the answer? Negative 1, because odd powers always you get negative answers. Write down the answer at once. This is positive power, always 1. Positive powers, always you get 1. Positive, even powers always positive 1. What about odd powers? Odd powers you are getting negative 1. For any power with negative 1 and odd power, always negative answer. Find the value. So, even power. So, always even powers, positive answers. So, what's the answer? You get minus 3 times minus 3, positive 9. Minus 4 times minus 4, you get positive 16. Minus 5 times minus 5, positive 25. Minus 7 times minus 7, positive 49. Minus 10 times minus 10, positive 100. So, you get all positive answers. Write down the following product of powers as a power of a product. So, 2a and b, both same power. So, you can write 2ab whole thing squared. Now, like that, can you write this one? Power 3 is there. And what are the terms here inside? 3x, y. Here power 3 comes. What are the letters inside? P, Q, R. This one, power 4. What are the numbers? X, 5a. When you are writing in order, normally numbers first. 5, a, x you can write like that. This one, power 3 is there for all numbers. So, 2abc. So, you can write 2abc to the power of 3. Show that 2x to the power 3 and 3y to the power 3 is 216, x to the power 3 and y to the power 3. So, what you do? You can take the left hand side and simplify and you show the right hand side. So, 2x to the power 3 and this one I can write as power 3, 2x and 3y. Then again I can write 2 times 3, 6x, y to the power 3. Multiplication of 2 and 3. Now I can write 6 to the power 3, x to the power 3 and y to the power 3. What is 6 to the power 3? 6 times 6, 36. 36 times 6 is 216. X to the power 3, y to the power 3. So, this is same as right hand side. So, this is left hand side. So, we can see left hand side is equal to right hand side. So, that means this is true. Show that this one. So, same thing, you take the left hand side and you have to show this is equal to the right hand side. So, how can you write these two? Same power. That's 2. 5x and 7y you can write like this. And 5 times 7, 35 xy squared. That means 35 squared, x squared and y squared. So, what's 35 squared? 35 times 35. Do you know any easy method? This is what you do. So, always you get 25 as the last digit when you multiply by 5 times 5. And how you get the previous number? You have to multiply by the next number. So, 3 is there, multiply by 4. 4 times 3, 12. So you are getting 1225. We'll check that. 35 times 35. 30 and 5. And 5 times 5, 25. 15 plus 2, 17. So you are getting 1225. So use that easy method to find out a square term. Only when it's 5 as the last digit. So you get 1225 x squared y squared. So that's right hand side. So that means this is true. Show that this one is the same as the other side. So take the left hand side. And we can see square term is common. Inside you get 11x and 2y. 11 times 2, 22xy to the power 2. So here 22 squared, x squared and y squared. Now what is 22 squared? 22 times 22. 20 and 2, you get 484. So that's correct. 484 x squared y squared, that's equal to right hand side. So we can say this is true. Find the value of algebraic expressions with indices. Now you have given a value for x and asked you to find out the value. So just substitute the value instead of x. So we can write 2 instead of x, I can write 3. Then 2 times 3 times 3. 3 twice there. So 2 times 3 is 6. 6 times 3, 18. So the value is 18. Now substitute here. 2 times 3 squared. 2 times 3, 6 squared. 6 times 6 means 36. Here 3, x is 3. 3 to the power 3. Altogether how many 3's? Now here 1 and this is 3. How many 3's are there? 4 3's are there. 3 to the power 4. What's the value? 3 to the power 4. 81. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. This one, 5, 3 squared. So 5 into 3 times 3, 9. 9 times 5, 45. 4 times 3 squared. Now 4 times 3, 12. 12 squared means 12 times 12. 144. 7x squared. 7 into x is 3. So 3 squared. What is 3 squared? That's 9. 9 times 7. What's the answer? 63. Find the value when a equals 2 and b equals 3. So we'll substitute. A is 2. So 2 to the power 2 and b is 3. 3 to the power 2. 2 to the power 2 means 2 times 2, 4. 3 to the power 2 means 3 times 3, 9. 9 times 4, 36. This one, 2, a. A is 2, b is 3. To the power 2. Now we can simplify inside. 2 times 2, 4. 4 times 3, 12. 12 squared. What is 12 squared? 12 times 12. 144. A to the power 3. That means 2 to the power 3 and 3 to the power 1. 2 to the power 3. 2 times 2 times 2. 8. 8 times 3. 24. This one. 5 is there. A means 2 and B is 3. So 5 into 2 to the power 2 is 4 into 3. 5 times 4, 20. 20 times 3, 16. Substitute here. A is 2. B is 3. So what's 2 to the power 2? That's 4. When you multiply 3 times 4, 12. 12 times 3, 36. 7. A squared. A squared means 2 to the power 2 and 3. So 7 times 4 times 3. 7 times 4, 28. 28 times 3, 84. Now we'll look at the review exercise. Complete the following table. You have given numbers and you are asked to write in index notation and base and the index. So the first one done for you. 8 is 2 to the power 3. So 2 is the base and 3 is the index. Now we'll do 9. So 9 means 3 and 3. You can write 3 squared. 3 squared, what's the base? 3, index 2. 16, you have given 2 is the base. So what is 16? We know that 2 to the power 4. 2 to the power 4 is 16. So base is 2, power is 4. And here base is 4 given and power is 2. So what's the number? 4 times 4. 16. Now 1000 is given with base 10. So 10 to the power 3. Here we just count number of zeros. So 10 is the base, power is 3. Expand and write each of the following expressions as a product. So what is 3x squared means? 3 times x times x. What's 2p squared cube means? 2 times 2 p's and 1 q. This one 4 squared means 4 times 4. X cube means x 3 times. 5 squared means 5 into 5. And x squared means x into x. And y squared means y and y. So this is the expanded form. Question number 3. Write down each of the following numbers as a product of powers of which the bases are prime numbers. So you have to find out the prime numbers. Take 20, divide by 2, divide by 2 again, and you can divide by 5. So how can you write 20? 2 times 5. And we can write as power 2 to the power 2 and 1, 5. 48. You have to divide and see. Divide by 2, divide by 2 again. Again, divide by 2. So you get here again 3 and 3 with 1. So 2 times 2 times 2 times 2 times 3. You can finally write how many 2's are there? How many 2's? 4 2's and 1 3. 100. 50. When you divide again 25, divide by 5, you get 1. So 2 2's and 2 5's. You can write 2 to the power 2 and 5 to the power 2. 145. Divide by 2, you get 72. Again divide by 2, 36. 18. 9. When you divide this by 3, you get 1. So how can you write? How many 2's? 1, 2, 3, 4. And how many 3's? 1, 2. Write 64 in index notation with base 2, with base 4 and with base 8. So first we'll find with base 2, divide and see. you get 2, 4, again 2. So how many 2's are there? 1, 2, 3, 4, 5, 6. 2 to the power 6. Now how can you find with base 4? So you can check how many 4's are there. We know 2 times 2, 4. Here we can check how many 4's are there. How many 4's? You can get 3 4's. Now the base is 4. 3 4's. How many 8's are there? 2 times 2 times 2, that's 1 8. 2 times 2 times 2, another 8. So how many 8's are there? 8 to the power 2. So you can write the same number in base 2, 4, 8 here. Example number 1. Express each of the following powers of products as a product of powers of the factors of the given product. So you can write this one as 2 to the power 3 x to the power 3. Or you can, without multiplication also, you can write 2 to the power 3 x to the power 3. This one. You have to consider power for all numbers and letters. 3 squared, a squared and b squared. Express 36x squared as a power of a product. So what is 36? 36 we know 6 times 6. So we can write 36x squared as 6 squared x squared. Now same power, power 2 is there. So you can take inside 6x. So 6x whole thing squared is 36x squared. Express a3 b3 as a power of a product. Same power 3. You can put a and b inside. Exercise 10.1. Express each of the following powers of products as a product of powers of the factors of the given product. So power is 2, you can write 2 to the power 2 and 5 to the power 2. Here you can write 3 to the power 3 and 5 to the power 3. This one, you have to consider all numbers inside with the power 3. 11 to the power 3, 3 to the power 3 and 2 to the power 3. This one, a squared and b squared. Here, consider power 5. This one, power 3. 4 to the power 3, x to the power 3 and y to the power 3. So without multiplication also you can write. 5a whole thing squared. This means 5 squared and a squared. 6p whole thing squared means 6 squared and p squared. 4y to the power 3 means 4 to the power 3 and y to the power 3. 3a to the power 3. 3 to the power 3 and a to the power 3. 2y to the power 4. 2 to the power 4 and y to the power 4 there. 2ab whole thing squared means 2 to the power 2, a to the power 2 and b to the power 2. Question number 2. Find the value of each of the following powers of products. Write each power of a product as a product of powers of the factors of the given product and obtain the value again by simplifying the answer. How can you write this one? You can write as 2 to the power 3 and 5 to the power 3. Consider power for all numbers. What is 2 to the power 3? That's 8. 5 to the power 3. 5 times 5, 25. 25 times 5, 125. So what is 125 times 8? 1000. This is 1000. Here you can do this one in another way. So if you simplify inside, 2 times 5, 10. 10 to the power 3. You can straight away get that's 1000. 3 zeros there. This one, 2 into 3 to the power 3. That means 2 to the power 3 and 3 to the power 3. What's 2 to the power 3? 8. 3 times 3, 9. 9 times 3, 27. So what's 8 times 27? 216. What's the other way? You can do inside. 2 times 3, 6. 6 to the power 3, you get 216. This one, 11 to the power 3 and 2 to the power 3. 11 to the power 3, 11 times 11, 121 times 11. So what's the easiest way to do? I told you, you can get it straight away. So here 1 and 1 there. 2 plus 1, 3. 2 plus 1, 3. So 11 times 11 or 121 times 11. When you multiply by 11, you can use the short method. So 1331 times 8. So multiply. 8 times 1, 8. 8 times 3, 24. 2 remaining. 8 times 3, 24 plus 2, 26. 2 remaining. 8 times 1, 8 plus 2, 10. So 10,648. What's the other method? 22 to the power 3. This one. 3 squared and 7 squared. 3 squared means 9. 7 squared, 49. So 49 times 9. 9 times 9, 81. 9 times 4, 36 plus 8, 44. So 441. So what's the other way? 7 times 3, 21. 21 squared is 441. This one. 5 to the power 3 and 7 to the power 3. 5 to the power 3 is 125. 7 to the power 3. 7 times 7, 49. 49 times 7. 7 times 4, 28 and 6, you get 34. So that's 343. So 343 times 125. 120 and 5. So 343. 2 times 3, 6. 2 times 4, 8. 2 times 3, 6. 5 times 3, 15. 1 remaining. 5 times 4, 20 plus 1, 21. 5 times 3, 15 plus 2, 17. So when you add it, you get 42,875. This one. So what's the 13 squared, 2 squared and 3 squared. So you have to do separately and multiply. 13 squared, 169. 13 times 13. 2 times 2, 4. 3 times 3, 9. 9 times 4, 36. 169 multiplied by 36. 3 times 9, 27. 3 times 6, 18, plus 2, 20. 3 times 1, 3, plus 2, 5. 6 times 9, 4, 54. 6 times 6, 36. 36 plus 5, 41. And 6 times 1, 6 plus 4, 10. So when you add it together, you get 6084. The answer is 6084. You can do other way around as well. 3 times 2, 6. 13 times 6, 78. 78 squared. 78 times 78. How you do that? 70 and 8. 7 times 7, 49. Plus 5, 51. And here again 8 here. 8 times 8, 64. And 8 times 7, 56 plus 6, you get 62. So when you add it, 6084. Express each of the following products of powers as a power of a product. So same power. I can write this is 5 and 2 inside. What is 5 and 2? This is 10 squared, but this is the final answer. So you can write as a product. This one 5 and 11, you can write 5 and 11 inside and the power 2 outside. Same power 3, so you can write the other numbers inside. This one power 2 is there, x and y inside. Same power 3, p and q inside. Power 5, a, b, x inside. 100. 100 is what? 10 squared. So this one you can write 10 times m inside and the power 2 outside. 225 is, what's the power? 15 times 15. So 15 squared. You can write 15 and t inside and the power is 2. 8, how can you write? 8 we know, 2 times 2 times 2. 2 to the power 3. And now you can write 2 and y inside. The outside power is 3. Show that 1000x cube is 10x whole thing cube. So you will take left hand side 1000 x cube. What is 1000? 10 to the power 3 and x to the power 3. Now we know same power. You can take that out and 10 into x inside. So no need to write 10 times x. I can write 10x. So this is the same as the right hand side. So this is true. Example number 1. Find the value of negative 2 to the power 4. We know that any negative number with an even power always positive. So you get a positive answer. So minus 2 times minus 2 times minus 2 times minus 2. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16 is the answer. You get a positive answer. This one, odd power. So what is the answer? You get a negative answer. Minus 5, 3 times. 5 times 5, 25 times 5, 125. So The answer is negative because the odd power of a negative number is negative. Exercise 10.2, find the value. We know 1 to the power any number is 1. Depend on the power, you get negative or positive. Odd powers, you get negative. Even powers, you get positive. So, odd power, so you get minus 1. Even power, you get positive 1. Here, odd power, 3, negative 1. Even power, positive 1. Here, positive numbers, 1 to the power any number is 1. 1 to the power 1003, 1. 1 to the power 2018, 1. 1 to the power 0 is also 1. 1 to the power any number is 1. Now this one, negative number to the power even, you are getting positive. So minus 4 times minus 4, that means positive 16. This is odd power. You are getting a negative answer. What is 4 times 4? 16. 16 times 4? 64. So you get negative 64. Even power now. You get a positive answer. So minus 4 times minus 4 and minus 4. That means 64 times 4. What's 64 times 4? 6 times 4, 424 plus 1, 25. So 256, this is positive. Minus 5 to the power 1. Odd power with a negative number, always negative. Here, even power. Even power always positive. 5 times 5, 25. Odd power, you get a negative answer. So, we got 25. 25 times 5, what's the value? 125, but this is negative. Negative number to the power, odd power, always negative. Even power, you get a positive answer. 10 times 10, that's 100. Show that this side is greater than. So what's left hand side? Minus 1 to the power 8. This is even power with a negative number, that's positive 1. Right hand side. Negative 1 to the power 9. Odd power. With negative, you get negative 1. So which one is bigger? So left hand side is bigger than right hand side. So this statement is true. So minus 1 to the power 8 is greater than minus 1 to the power 9. Miscellaneous exercise. Question number 1. Express each of the following products of powers as a power of a product. Look at this one. Same power 2 is there. So you can write 2 outside. What are the numbers inside? 2x and y. So without writing multiplication, I can write 2xy to the power 2 for this one. This one. Power 2 is the outside value because same power. 3a and b is there. So you can write 3ab to the power 2. This one, same power of 3. What's inside? P and 2q. So when you write in order, 2pq to the power 3. This one. Same power 3, 2x and 3y. So 2 times 3, I can write 6. xy to the power 3. Power 3 is the same. So you can write power 3 there. 5a and 2b. 5 times 2, 10. 10ab to the power 3. This one, power 3 is common. What's inside? A and 2b and c. So rearrange in order. Numbers first. A, B, C. 2a, B, C to the power 3. Show that this one is equal to the 36a squared x squared. So we'll take left hand side. 3a squared and 2x squared. What is 3a squared and 2x squared? I can take as power 2 because power 2 is common. Inside I can write 3a and 2x. Then what's the next step? 3 times 2, 6. 6ax squared. Then this means 6 squared, a squared and x squared. So what is 6 squared? 6 times 6, 36, a squared and x squared. So this is same as the right hand side. So this is true. Question number 3. Arrange in ascending order of the values. 2 to the power 3. What's the answer? 2 times 2 times 2, 8. Minus 10 to the power 1 means odd power, you get negative 10. Negative 1 to the power 10. Even power with a negative number, that's 1. So you get positive 1. 3 squared. 3 squared is 9. Now arrange this in ascending order, means smaller to bigger. What's the smallest value? Minus 10. So we can write negative 10 to the power 1. Then the next one, that's the smallest value. And the next one, 1. Negative 1 to the power 10. 8 is the next number, 2 to the power 3, and 3 squared is the largest number. So that's how we can write in ascending order. Take question number 2. Minus 2 to the power 4. This is even power. You get a positive answer. 2 times 2 times 2 times 2. That's positive 16. Minus 2 to the power 5. This is odd power. You get a negative answer. 16 times 2, 32. That's negative. Minus 1 to the power 4. Even power, you get a positive answer. That's positive 1. And odd power, you get negative 1. So what's the smallest one? Negative 32. So negative 2 to the power 5 is the smallest one. What's the next one? Minus 1. Minus 1 to the power 5. Third one is 1. Minus 1 to the power 4. And the largest one is 16. That's minus 2 to the power 4. If a is a negative integer, show that a squared is greater than a to the power 3. Okay, so here left hand side is a squared. So a is negative and power is even. Even power of any negative value is a positive value. Right hand side, a to the power 3. Odd power. Negative value odd power is always negative. So which one is smaller? Negative value is smaller. So a cube is smaller than a squared, or a squared is bigger than a cube. So here we can show that this is true. So we covered all theory related to indices. So this is an important lesson for grade 10 and 11 as well, and also grade 9. So here as a summary, what we discussed here, we discussed if a, b, c and n are positive integers, then ab to the power n you can write as separate powers. If you take a, b, c to the power n, you have to take separate powers. The value of any power of a positive integer is always positive. The value of an odd power of a negative integer is always negative, and the value of an even power of a negative integer is always positive. And also we looked at 1 to the power any number is 1. When you take negative 1 to odd power, you get negative 1. Negative 1 to even power, you get positive 1. So this is the last unit in your first term work. So practice this one and try to do the review exercise after this.